This tutorial is for 2nd grade, Module 6, Lesson 15. In this lesson, we're going to continue building arrays and writing repeated addition problems to match. The directions for the first problem say to shade in an array with 2 rows of 3. And you can see I have already done that. I have 2 rows, and there are 3 squares in each row. I can write my repeated addition problem 2 different ways. I could write 3 plus 3 equals 6, and the 3's refer to the number of squares in each row. Or I could write 2 plus 2 plus 2 equals 6, and the 2's would refer to the number of squares in each column. Either way is fine. In the next problem, I've shaded in 4 rows of 3. So here's my 4 rows, and there are 3 squares in each row. So again, the repeated addition problem could be 3 plus 3 plus 3 plus 3 equals 12. That shows my 4 rows of 3. Or I could write an addition problem showing the squares in each column. Each column has 4 squares, and there are 3 columns. So 3 groups of 4 would also equal 12. In the next question, I've shaded in 5 columns, and there are 4 squares in each column. So these are my columns, and you can see that they each have 4 squares. So one addition sentence could be 4 plus 4 plus 4 plus 4 plus 4 for a total of 20 squares, and each of these 4's represents the number of squares in each column. I could also write an addition problem showing the number of squares in each row. There are 4 rows, and each row has 5 squares. And that will also give a total of 20 squares for this array. Problem 4 says to draw one more column of 2 to make a new array. Right now I have 4 columns of 2, so I'm just going to add one more column onto the end. That means my repeated addition problem could be 2 plus 2 plus 2 plus 2 plus 2, which equals 10, and that shows my 5 columns, and there are 2 squares in each column. I could also write an addition problem showing my rows. That would be 5 plus 5, because there are 2 rows and there are 5 squares in each row, which also gives a total of 10 squares. Problem 5 says to draw one more row of 4 and then one more column to make a new array. So we'll draw the row of 4 at the bottom. So there's one more row of 4, and now I need to add a column, and we'll add that at the end. There's my extra column. So now I have 3 rows and 5 columns. I can write a repeated addition problem for this showing my columns. There are 3 squares in each column, and there are 5 columns for a total of 15 squares. Or I could show an addition problem showing the number of squares in each row. There are 3 rows with 5 squares in each row, which also gives a total of 15. Let's look at one more question. Question 6 says to draw one more row and then 2 more columns to make a new array. So we'll start by drawing one more row at the bottom. So that's going to add 3 squares at the bottom. And then we're going to add 2 more columns off to the side. So here are my 2 columns, and I'll draw lines to complete the array. So now I have 5 columns and 5 rows. For my repeated addition sentence, if I showed the number of squares in each column, that would be 5 plus 5, plus 5, plus 5, plus 5, for a total of 25 squares. And then you'll notice if I were to write a repeated addition problem showing the number of squares in each row, it would be the exact same problem. I still have 5 groups of 5. So there's really only one repeated addition problem that we would use for this array.